Hello and welcome back. Hi, I'm Daniel Zen, and I'm going to be talking about four-way data binding, which is using a library called ngPouchDB, allowing for offline data synchronization. And if you want copies of the slides, please mark down the URL now. They'll be available again at the end, but you might want to follow along. So a little bit about my background. I'm a longtime JavaScript and Java programmer. A lot of people are like, why JavaScript back then? It's not a real programming language, and we have proven that all wrong, especially with TypeScript and ES6 and everything else coming out down the pike. I am a former extreme programmer consultant. That was the term they used before Agile. So I'm very much into test-driven development and the like, although this particular library I'm going to display is not. I used to consult for Google and Pivotal Labs. I started the AngularJS NYC meetup back in May of 2012. And then I reformed my consulting company, Zen Digital, focused on JavaScript open source and design, agile software development, as well as user interface and user experience. I do corporate training for web, mobile, and custom interactive. And I also have been a magician and a fire performer. Okay, enough about that. Let's talk about this talk. What are the requirements for, this is the outline and what I'm going to go over. What are the requirements for AngularJS data models? What are the standard online techniques that are being employed? What are the offline issues that we need to deal with? What are our local storage options? And then we're going to have a sample application walkthrough. It's actually not Ionic PouchDB to do. I did an updated version. So it's to do ngPouchDB, and I'll be sharing that on GitHub later. And we'll be looking at the ngPouchDB collection. So first, what are the requirements for the data models in AngularJS? Absolutely nothing. That's one of the great things about AngularJS, that there's no imposition on you for how your data has to be modeled. So that's great, but that freedom can also come at a price of like, well, how should I structure my data, especially for storage and the like. But AngularJS is completely model agnostic. Any variable or object can serve as a model. There's no unique ID required, which other frameworks sometimes have. However, there's also no built-in persistence model for objects. ng model binds JavaScript variables to the user interface, not to the backend. So what does this mean for data persistence? There's no standard yet, although there is a document for Angular 2.0 design doc. There's various open source. Everybody's used probably SQL, PostgreSQL, MySQL, Mongo, or perhaps Couch. So, and typically we employ a CRUD, create, read, update, delete sort of model via a RESTful API. And we have the HTTP service that follows the promise interface, and that returns a promise object with this, a standard then method. Or we have the higher level abstraction of a resource. This gives us, it's a service in the module ng resource, and a factory lets you interact with server-side data. And this returns, once again, the resource with the methods for CRUD, and you have the operations get, save, query, remove, and delete. But what about offline and higher level abstractions? Something that makes my data storage easier. I don't want to deal with this model anymore. I'm dealing with a high-end interface, AngularJS, high-end framework, AngularJS, that allows me to simplify my code production. So why can't my data persistence also be simplified? So Google Docs is a good example of this. We have the mobile app version, we have the web version, and no matter where we are, there's an online and an offline version these days. It wasn't like that originally, but you can completely use Google Docs offline nowadays with synchronization built into the browser. And so for an offline first experience, you need to store the data in the front end in some way, shape, or form. And you need to be able to sync the server-side data store locally so that you can go on the subway or walk away from the internet and still be able to use your application. There's various in-browser databases that are available. Derby.js, Lawnchair, and SenchaTouch are some of the databases that I looked into. And what we want is online, offline synchronization capabilities. When we go online, we want to synchronize. And so what we've come to expect is that we should be able to use our email program when we're offline. There's a local copy of recent emails. We can read or delete them, and we can write a new email, and it'll send when we go online, and any deletions or changes we've made will synchronize. So that's the standard that all of our apps should be approaching at this point. And once again, Google Docs keeps pushing that threshold. And there's got to be some solution long-term for conflict resolution. What happens if I have two apps open in different locations and they're both offline and I'm modifying the data in two different locations and then we sync them up? Sort of like the Git model. There's got to be at some point where we've got to deal with multiple edits in different locations. And there's a connectivity lifecycle that takes place. Failures can happen when the client pushes the data, or the client pulls the data from the server, or the server pushes it back down to the client. So what would you do? You need to communicate to the user that something has changed, or you need to hide the connectivity state in some way. So for instance, a chat app will tell you in some way, hey, you're offline, your chat's not going to go through at this point in time. And certain apps treat it differently. For instance, Facebook chat will just say, hey, you can't send your message, but your SMS app will allow you to send it and will sort of keep it around and try to send it until you go back online. These are the sort of choices we need to make in our apps. So to enable client-side creation and editing features, such as in a to-do app, if I'm offline and I have a new item for my to-do list, I should be able to create it even if I'm offline. And we need to disable, modify, or hide features that just won't work. So Facebook, for instance, will not let you do a status update when you're offline, but still will show you the most recent status. Twitter tweets are similar like that. You need to notify the user about possible conflicting data, and once again, we need to have some sort of merge or conflict resolution tools. So how to deal with being offline. Right now, we've got this little dinosaur that sometimes shows up and says, you're offline, or unable to connect to the internet. So we need to stop treating offline as an error condition and take care of it in all of its different forms. We need to try not to block features completely. So if you can't update, show the old data, maybe with a message saying that this data may be out of date. Let users create data locally to be sent later. And dealing with new incoming data, you have options such as show the most recent data that's coming in, or show it in the chronological order that it was created. Most email apps nowadays will show new email at the top, but there was a time where you could choose to show an email when it was actually written, and so sometimes new emails would come in not at the top, and you'd have to sort of find them later because they might have got delayed in transit by SMTP or the like. So what are the local storage options? Well, you could wait for AngularJS 2.0. They're supposed to have local storage options. They talk about them. I haven't seen them yet myself. You could roll your own. We could use local storage, IndexedDB, or WebSQL directly, but that's not really the best solution. We should take advantage of libraries that are out there. There are proprietary solutions such as Firebase, or with Angular Fire, and Firebase will transparently reconnect to the server between an offline and online transition, but it doesn't persist to local storage, so you won't actually be able to modify your data while you're in an offline situation. And then open source local storage databases that sync, I found PouchDB. And that's a JavaScript implementation of CouchDB, and it synchronizes with a CouchDB server. And I found this to be an extremely useful implementation. So I said, hey, I want to use this in Angular. And so let's take a look at PouchDB. It's got pros, it's open source. AngularJS, open source, I'm big pro. It's a lightweight cross-browser JavaScript implementation. That's great. That means you can embed it almost anywhere. It syncs with an open source CouchDB database using the standard CouchDB protocol that's been implemented in several different databases. I'm actually curious, just while I'm here, how many people are currently using like Mongo? Can I just see a show of hands? And now, can I see how many people actually have used CouchDB in their applications? Okay, just a few. So, I mean, the reason why I was actually looking for something that did this in Mongo when I first started, because I like the mean stack. It makes things easy to, to employ a standard. But CouchDB had the built-in synchronization that I needed, and PouchDB implemented it. So that made this a lot easier. And I've been looking at various solutions and migrating certain solutions that I had in Mongo to CouchDB when I need to employ this type of model. And then, of course, we can also look at this model is generic. It's not something that's specific to PouchDB. The thing is, it's already implemented in PouchDB. So we could look into how could we write our own version of this for Mongo if we wanted. But that's not what I've done so far. So just letting you know. So here we're seeking with CouchDB protocol servers. We've got PouchDB server, CloudInt, Couchbase Sync Gateway, and this is standard Apache open source. So what are the cons? There's no standard AngularJS library. There's this Angular PouchDB. There's actually two competing standards for it, and I've grabbed one and sort of rolled it into my library. So let's take a look at the sample application that I've created. And once again, it's I'll be posting this. I'll update this. The name of it. It's to do ng PouchDB, and the source code will be available at GitHub Daniel's End to do ng PouchDB. So I'll update that. So first, let's take a look at a simple to do app that doesn't actually use to do PouchDB. So this is just basically, this is an app that I usually use for an Ionic starter class. I go through some steps and I create this app very quickly in about 15, 20 minutes. But because I don't have an additional 15, 20 minutes, here it is already created. It basically has a number of to-do items. You can click on an item to toggle its completion state. You can slide an item to edit its title and give it some change, or you can delete an item. Simple. And let's take a look at the code to see how that was implemented using Ionic. You've probably sat through a number of Ionic demos over the last 2 days, so hopefully this will be pretty familiar to you. So here's the HTML for the Ionic, and this is it. It all fits on a single page. So basically, we set up the Ionic. We have a pane, and within that pane, we have a title. It says to do. We have a button that when we click creates a new task. And then we have a list of tasks. And when we click on a task, it toggles the completion state. And the class that represents the task will change based on whether or not it is completed. So it'll be slightly grayed out and be underlined. I'm sorry, have a line through it. And we have an arrow pointing to the left that indicates the fact that we can have these ion option buttons that allow us to slide the list item and access either the delete or edit buttons that are hidden underneath, and they're colored with classes for assertive and energize, which give them their color. That's all the HTML right there. Let's take a look at the actual app. And once again, this is pretty much all of the, oh, wrong one. This is all of the code here. All fits on one screen. So I've pre-populated the tasks with first, second, third, and fourth, and I've set the first one to be completed and the others to be not completed. I have a toggle completion method that that gets called when I click, and that just basically says the task's completed variable is set to, is knotted. And we have delete functionality that basically splices the item out of the array that represents the tasks. And we have a new task that calls Ionic pop-up. This gives us a little pop-up that allows us to type in a new task. I don't know if I actually displayed that. So what do you need to do? And usually I say teach Ionic, but since I only have one hand, I'll just give it a little, there you go, create task, and bam, there's a new task. So we have a little pop-up for a new task, and we have a similar pop-up for edit, which has a slight little hack so that I can pre-populate the pop-up. And that's it. That's the whole app. So that's great, except what about data persistence, synchronization, and all that? Well, I just wanted to show you what needs to be added to this app to gain that functionality. So I'm going to show you all of the code that I've added using the ng PouchDB library. I'm going to compare these two files. So basically, I had to include the PouchDB libraries. I hope this is large enough for everybody to see. So I had to include the PouchDB libraries, and I renamed the app to do ng app. And then I have a slight little hack here that allows me to mimic. There's a button here that's called toggle online state. It allows me to mimic the concept of being online or offline. Actually, I should give a demo of the app before I go over the code. It's typically what I do. So here is a very similar version of the app, except of course there's nothing in it to begin with because this one actually has data persistence. So if I create a new item and I enter, what do I need to do today? This is where it gets hard. Okay, so we've created a task, and there it is. I can create a task, and then I can, let me show you the back end here. There is a database that represents, this is the CouchDB database, and there's absolutely nothing in it yet because I've set this up to be in an offline state. That little exclamation mark is supposed to symbolize the fact that we are still offline. So if I click this button, now we're online. We've exited the subway. And if we go and look now and refresh, we'll see that suddenly there's an item in the database. And that's because as we stepped out of the subway, it automatically synchronized with the server. So that's great. Now here's another one. Here's I've done this maybe from the website or on my Android device. And now I've got an iPhone 6 over here. So when that iPhone 6 goes back online, it instantly gets the information synchronized from the server. So now I'm able to symbolize having two devices, and I can make them go online or offline. So let's put them both offline and create, I don't know, a web task here, and create a mobile task here. And then we can put them online and online, and we can see, bam, the information got synchronized between the two of them. So this is the functionality that's been created. So let's take a look. How much code did I need to add to not only be able to persist my data to a server, but to actually create this offline data synchronization? So now we're back to here. So this is that button I was telling you that kind of mimics the fact that I'm offline. And now, what are the changes in my code? Okay, here's one change. When I call the delete, instead of passing it the actual task I want to delete, I have to actually, instead of passing the index that I want to delete, I have to actually pass the task. Okay, that was one small change I had to make to the UI. But besides that, all the code has stayed the same on the user interface. Now let's take a look at what code actually had to be added to the application in order to get this functionality. Okay, a little bit more. So at the very top here, we got rid of the pre-population of our 4 tasks and instead replaced it with a pouch collection. And pouch collection is one of the methods that's available from the ng-pouchdb library. So we said, oh, we're going to have a database called to-do ng-pouchdb, and we're going to create a pouch collection with it. So now, when I toggle completion, I have the exact same code there, but at the very end, I have to do an update of the task. I say scope tasks, which is my collection, update this particular task. So by doing that, I'm both persisting to local storage and, if I am online, storing in a remote database. So that's one change I had to do there. For delete, instead of splicing the item out of the database, I have to call remove. Now notice these $update and $remove. These are methods, once again, that have been given to us in the pouch collection by the ng-pouchdb library. But basically, those are the only changes for both modifying the completion of a task or to delete a task. The pop-up is pretty much the same, except instead of pushing a new task onto the tasks array, I have to add the task. But essentially, it's the exact same code, except instead of push, I'm saying add to the collection. Once again, $add provided by the ng-pouchdb library. And now let's take a look at edit. I actually added a little bit of extra code in edit. I made sure that the title was actually changing. Because if we're going to make edits and then say, and not actually make a change, we don't want to do an update because that would then force some internet traffic to actually not make any changes. So I actually added a little extra test that I didn't do in the first version. I say, has the title actually changed? So here is the old title, here is the new title, and only if they're not equal do I actually update the title. And then I call update on that task, same as I did with toggling the completion state. Everything else here, this is that little hack for being able to toggle the online state. So that's actually not really part of the code. I just put that in so I could give the demo. So that's really a very small change to go from an app that's completely offline to not only online, but online with data synchronization, as long as you're using the CouchDB database at this moment in time. Checking my time. So let's take a quick look at the actual library for. So here we are, the actual ng PouchDB library. Here's the collection. So this is the actual code that does it all, and it's about 3 pages long. And obviously I can leave this as an exercise for the reader, but essentially this library is open source, it's MIT licensed, it's available for anybody to update, modify, use in their code in any way, shape, or form. And it's what it basically internally uses like add child, remove child, update child concepts, and it's listening in for any modifications to the database and updating them in the local model, and you have to actually say, I'm making changes to the model at this point in time. But eventually, we could actually be listening for changes to the model and automatically be pushing those changes to the remote database as well, making this an even more seamless experience for you to integrate into your application. I think that's it. I think I'm up on time now as well. Thank you very much. Hopefully this was useful. Oh, and here's just a little model so you can understand what two-way data binding is. Our standard AngularJS. Three-way data binding is something that Angular Fire talks about a lot, where the user interface and the data model synchronizes with the remote server. And then here we have the four-way data binding model, where the user interface and the data model are kept in sync, along with a local storage, PouchDB. And then if the internet is available, we are syncing PouchDB to the remote CouchDB database, thus enabling four-way data binding. Thank you very much.